Okay, so did I start recording? Yeah, okay, good. Thanks again. So basically, like in an assignment operator, you have a left-hand side variable that takes as as a value, either like an immediate value, a numerical one, or another variable, or a complete expression on your right-hand side, right? An example here is if you say y equals 7 multiplied by 3 minus 8, whatever the mathematical expression you have here. First of all, you remember from yesterday that the type of y dictates what are the possible correct values of the variable y. Then this expression has to evaluate to a correct value for y. For example, uh, if this evaluates to a string or a character, well, character might be fine, but if it evaluates to a string while y is an int, then that's a problem, right? It cannot really work. But here, well, it evaluates to an int, assuming y is an int, so this should be fine. And then C has some way of really adding, so, and this is related to the assignment operator a little bit. It's called usually compound assignment or overloading assignment. You do the assignment and one additional operation. What do we mean by this? So let's have an example. If we say x plus equal 3, then that really means as if you are saying x equal x plus 3, right? So the compiler understands this exactly as that, right? Good. And then the same thing for the subtraction, multiplication, division, and modulus operator, right? Well, if you're not very comfortable with this, just feel free to use the normal way. Sometimes people like it's more like a style, right? So it doesn't add any extra functionality, and it's completely up to you. Good. And then two unary operators you have to be aware of, and we have seen one of them in the for loop, which is pre-increment and post-increment. So simply, for the pre-increment or like pre-decrement and post-decrement is the same thing. I just want to jump to the example. So if I did something like this is saying I want to increment x by 1. So this is as if you're saying x equal x plus 1. Good. But well, maybe the difference here is that when you do the post increment or pre-increment, you can really do this as part of a big expression, right? As we will see as an example. The main difference between post and pre is that post increment, if you have a big expression and you do a post increment in, the value of x is incremented only after you calculate the overall expression. What do I mean by this? Might be a little bit confusing, but just remember the name post increment, which means I only increment after everything else, right? And pre-increment, you increment before you do anything else in your expression. And I have few examples about this. But before jumping into examples, you need to know that those only apply to variables. They don't apply to immediate values. You cannot say plus 5, for example. What is the reason for this? It really makes sense because saying x plus plus, we said it's equivalent to say x equal x plus 1. There is a variable that has a memory location that you can store the expression result in, right? But if you say plus 5, well, that's an immediate value. There is no memory location at all that holds the result of the expression. Then, well, it cannot be done, in fact, right? And this is similar to say, well, I cannot say equal 5 equal x plus 1 because 5 is really not a memory location, right? And then you cannot also really like do something like this, like post increment an expression. That's not possible. You have to post increment a variable, right? If you want to do something like this, then you might say x equal x plus 3, or maybe y equal x plus 3, and then you increment y, right? In two separate statements. Good. Yeah, so this is stating what I was saying right now is if you do a pre-increment, this increments the variable before you use the value of the variable in the expression. And there are tricks on this. Like we also used to have this as like multiple choice questions before, but I'll show you a few examples, right? And the post increment does the other way around. Like you only increment the variable after the expression is being evaluated. So let's look into examples. Here I'm defining 3 int variables, I and A and B, and then I is initialized to 1, A to 0, and B to 0. Then if I do something like this, I say A equal plus I. First of all, there are two things that should happen in this expression: the pre-increment and the assignment, right? Which one happens first? According to the rule, pre-increment should happen before anything else in the expression, which means I get incremented first. So I moves from 1 to 2, which means I'm assigning a 2, correct? On the other hand, if I say, well, I put I back to 1 now, and then if I say b equal I plus plus, that's a post increment, which means I only increment I after I assign I to b, right? So after I evaluate the expression. So in this case, so let me just do this. Here, this can be broken down into two different statements. The first statement is I equal I plus 1, and then a equal I. So in this case, I is 2 first, and then a equal 2, correct? This can be broken also into two different statements, but the first statement is b equal I. You see here we flipped it, right? And then I equal I plus 1. And then which means b will be 1, and then I afterwards will be 2. What did happen is I incremented I first here. It's a pre-increment. I incremented I next here, which is post-increment. Good. Questions about pre and post-increment? Okay. And then some of the kind of relational operators that we usually use in conditions, larger than, less than, larger than or equal, less than or equal, and then checking equality, and then checking non-equality. One thing, I don't know if I have notes about this here, maybe not, but one thing that is I see most commonly used as a mistake or a bug in the code that is very, very hard to track down in C especially, is if you do something like this. If you say if X, so the normal thing, if you want, for example, to say something, well, I'll give you one example of something we have done ourselves. If we said X, which is your input, modulus 2, whether it's equal, back then we wanted it to be odd. So we say something, for example, if it's equal 1 or not, right? Remember our very first example when we're taking inputs, and then we check whether it's odd or not. If that's the case, that means X is odd, correct? And we have wrote this code if you go back to the previous lectures. What is the problem? This is a correct code. There is no problem at all. The problem is that sometimes people forget the second equal, right? Why that's a problem? Because C will not complain. Like the C compiler will not tell you that really, oh, you are doing a checking equality, but you're doing an assignment operator. What the compiler will do instead, but that's really an expression. Okay, so maybe I should do something different. Let's say y equal x modulus 2, and then here I'm checking this, right? So if I do this, that's correct. That's completely equivalent to the example that I had before. But if I forget 1 here, what the compiler will do is it will really assign y to 1. So the value of y will be 1, and then it will check the equality afterwards, which means this condition will always evaluate to true, right? But this is not what you want to do, right? You want to check equality, which means, well, the compiler will not give you any error. When you debug your code, it will not behave as expected. And, well, you spend hours debugging it, right? One of the things to pay attention to is to check whether you really did a checking equality or equality operator, or you did an assignment operator. There is an easier way. There is a good programming practice to really avoid this mistake by nature, by your coding style. What is it? It's usually you start with the immediate thing, because if you do something like this, which is also a valid expression in C. If you do this, you are checking whether y equal 1 or not, the same thing. But if you forgot this, well, we said before you cannot assign something to an immediate value. So now you will get a compiler error, right? So if you forgot by mistake that an equality you did an assignment, you will get a compiler error. So you usually start with the expression on your left-hand side instead. This will guard you against forgetting this equality checking. Oh, what did happen? Automatic restart. I'm still in the desktop, right? I still see you guys moving, but for some reason my tablet has restarted. Windows again. I guess the Linux guy on the chat will say another joke now. But let me. Okay, so maybe I can just pause for a second and take questions. Okay, so I came back here. I'm still sharing. Just make sure yes. Then I will join this device. And then I will reshare. And then full screen. Oh, I did stop sharing. Interesting. Like I'm sharing from here, but I don't see it on the other machine. And I believe you guys don't see it, right? You don't see the PowerPoint slides? Quite interesting. So maybe I just exit the call. Oh, that's because there are two meetings going through. Why like you guys started two meetings in the same channel? Let me see. Yeah, I just hope that no one would be in the other meeting by mistake, right? But I do see that someone sent on the chat. See that I'm sharing here, but it seems still not appear. So I'm seeing that my tablet is on the other meeting then. Okay, let me leave. And then see which one we are in. Are we in general? Add this device. Then share. Now this should appear. Okay, so now we are good. Okay, and we are still recording on the machine. Good. Okay, let me quickly check questions. Okay, so I will. One thing we can do for this to check is, well, previously I've been using Zoom. In fact, it was a single link. So something I would check is maybe before I start the lecture, I would make sure there is a single meeting going on, and if there is another one, I would just close one of them. So I guess just to make sure you guys don't go to different meetings. Okay. So we went through this. We had the examples. Why I'm not able to remove them? Okay. So the not operator is simply, I do believe you are aware with some of the logical operators in digital design, right? Like what is a not, what is an AND gate, what is an OR gate, right? So the logical negation operator or the not operator is exactly as if it's a not gate, right? Simply just negate the value. If it was true, then not the expression will evaluate to false, or the other way around. If it was false, it will evaluate to true. Good. And then, for example, here is 7 less than or equal 6? No. So this evaluates to false, which means not false will evaluate to true. Correct? And then and or is also like the logical and operation, which means both. Well, the final big expression will evaluate to true only if both expressions are true, right? If you remember an AND gate, if you have true and true, that's the AND. This will evaluate to true. If it's true and false, it will evaluate to false, false and true, to evaluate to false, and then false and false will evaluate to false. So you only have true if both expression 1 and, this is the meaning of AND gate, and expression 2 is true. On the other hand, if you have an OR gate or an OR expression, then well, it's only sufficient to have this expression or this expression to evaluate to true. So you have true, true, this gives you true, true, false, or false, true. This would still give you true. And then false, false is the only case that gives you false. So you always evaluate to true, except the case both expressions are false, right? That's the difference between or and and. Good. Do we have examples in this slide? So, for example, here, if I say, well, first of all, I cannot really write this in C. So that's really mathematically correct, but you have to break it down similar to Python or any other language. Those has to be separate, two separate expressions. So if you want to check if A is between 2 and 6 inclusive, what you would do is to say, is A larger than or equal to 2? And because we say, well, it has to be between the and so you want A to satisfy these two conditions. Does this make sense? Good. So that's really what we wrote here. And then, well, let's look to another example to make sure you get this. If we say A is larger than 2 or A is if A is int. So if we say is the first expression, well, if you have 2 here, is A is less than or equal to 2 will be true for all these numbers, correct? Oh, we'll talk about larger, sorry. So simply it will be true for all of this. 6 means it will be true for all of this, which means this expression will always evaluate to true in fact, if A was int, correct? Because if A is int, one of these conditions is always true, right? Does this make sense? Okay, and this we went through the truth table already. We have seen this precedence table before. The thing to know is that your logical operators really become last before your assignment ones, right? So that's the last thing you evaluate. That means if you have an expression and then a logical like and expression, you have to evaluate all your expressions before you really do the logical operation. Good. Well, this simple program thing is just we have went through so many programs by now, so that's really nothing new for you. Yeah, that's more like some hints on how someone of you asked already about the unsigned, and I gave the example yesterday about the time. The good thing about unsigned is it saves you some memory. It gives you more space to have more values for your variable. For example, if you know that you are going to always use your variables for time-related calculations, a day, a month, or a year, it has to be unsigned. And as you can see here, it's a good thing to really call them something meaningful. Like don't call them X, Y, Z, and then use X for day, right? Like later on you forget, and whoever you give your program to will also forget. And something that you pay attention to is in the lab marking as well as the midterm and final marking. These things really will deduct marks. If you use unlogical names, if you don't add proper comments, well, not in lab 0, most likely not in lab 1, we will be like less strict on this. But over time, I'm hoping for starting from lab 2, we really give grades for good comments, right? So make sure you really exercise this good programming practice. Well, that's not allowed because these are not proper variable names. You cannot have something that has special character as part of the name. You can do multiple assignments and declarations in one line, and we have seen this before. You have to end it by semicolon. By now, we should be familiar with this. All of this is revision. One thing to mention here is this is a valid statement in C, right? Like, for example, if I write something like if, go back to our very first example for checking odd and even, right? We wanted to only add if it was odd. So I can write something like if X division by 2 equal 1, then I just add some equal whatever, then I can just say else and then semicolon, right? That's a valid statement, which means in the else path, I don't want to do anything, right? Good. Okay, this is because we are forgetting the semicolon. We cannot have a comma. Good. And then jumping into the conditional statements, this is more, again, it's a revision, but it's good to put all the rules in front of us. If I have an if-else statement, this is the flow chart of an if-else statement. So simply, I have a condition. If it evaluates to true, I'm going to execute the action of the if, which is here action A. If it evaluates to false, I'm going to evaluate the else path, which is action B. Good. As simple as this. And then if you only have an if, you don't have an else, then really if you do false, you do nothing, right? So there is nothing to be done. And here, well, let's take an example to see how different ways of writing if and if else would be equivalent. So here what I'm doing is I'm saying if x is less than y, then z equal x, else z equal y. What does this code do? It simply assigns z to the minimum of x and y, correct? So if x is smaller, then z will take x, otherwise z will take y, right? But simply, I can just say, I can write it in another way. I can initialize z to any of them. It doesn't really matter. Do a single checking condition and update z if the condition does not satisfy, right? So both will really give you exactly the same result. Can I write it in a different way? Do I have a third variant? Well, I can initialize z to x instead, right? Then say if x is larger than y, then z should be y in that case, and then I print, right? That's also completely equivalent to all of them. These are different ways of writing the same logic, right? And then if I have a nested if, so I have if statement and inside the if or the else, I have another if statement, which is very valid. That's the, I would say, the general flow chart of such nested if. That's your first condition. So let's say I have an if condition 1, and then if condition 1 is true, I have another if for condition 2, and then I do something here. I believe I do action C, and then else I do action D, and then, well, if the original condition is false, I really do else action B. Right, that's the equivalent code of such flow chart. So let's go through it quickly. What do I do is I have an if condition. If it evaluates to true, I'm going to execute the block of the if statement. But this block of if statement itself, which is really all of this, can be any other code, which includes another if condition, right? So you would have another if and else, but then if this is false, you would have to jump to the else block, which has a single expression action B. Good. Then, well, this might be kind of very simple, but something very important to pay attention to is if you have a mix of conditions, there is another way really to write all of this, because you want to see, first of all, for action A, maybe I just write them A, B. Do we have A? So we don't have A, so we just have B, and then C, and then D. And then you really have two conditions, condition 1 and condition 2. And then to understand your logic, to say, well, what will make action B execute? Action B will execute is, in fact, condition 1 is false regardless of condition 2, correct? If condition 1 is false, I never check that. What makes action C executes? This has to be true, and this has to be true. What makes condition D executes? This has to be true, and this has to be false, right? Take this as a good exercise of how to rewrite exactly the same logic without the nested if, right? Think about it, and maybe if you got questions, like ask me during office hours or ask the TAs. But it's a good way to think of, well, that's a very simple code, 3-4 lines, but the important part is to understand the logic behind it, how to formulate the problem or the algorithm again into coding in different ways, right? Are there questions? So I'll stop to take questions. Oh, I was lagging in one of the. Okay, Mayar, what does y equal x mean? So simply, well, y equal x modulus 2, it's like that's the modulus operation. So y will take the remainder of the division of x over 2, right? So if x was even, then y will be 0. If x was odd, y will be 1. Okay. When would you need to use pre-increment as opposed to post-increment and vice versa? Peter, that's use case dependent. This depends on your application. If you know that you want to update, and you will know it when you see it, right? So simply once you understand the post and pre-increment, when you need to evaluate I before you start your expression or increment it, then you will do it, right? Hopefully through the programs we write throughout the course, we will encounter multiple of these instances. Any other questions I'm missing? It's a long chat. Okay. Okay. Maya, there is no I at the end. Maybe I have just wrote this by mistake. There is no I at the end, right? Good. Okay. That's also a similar thing. Is that the case? True, false? Yeah, in this case, we just really reversed it. So we're having our nested inner if condition inside the else instead of having it inside the if, right? Which makes C, for example, evaluates if condition 1 is false and condition 2 is true, right? So that's the other way around. Yeah, and then loops. Good. So while, do, while, and for. So for the for, we have seen multiple examples before. Let's take the general rule. For has generally the line of the for takes 3 statements. The first one is your initialization expression. The second one is your condition to exit your loop. The third one is your increment expression, right? And here what statements you want to execute once you are inside your iterations. To model this as a flow chart, simply here you have your expression one as your initializer. You go ahead and check your condition. If your condition is true, you execute the statements. Then you check your exit condition. If your exit condition is false, then you continue executing the loop. Otherwise, oh, so that's my mistake. Sorry, that's your exit condition. This is your increment condition. So you will. That's basically what makes you progress in your number of iterations, and then go back, check your condition. You will keep in this loop until you hit your condition to be false, and then you exit. Right? It's very important, by the way, to learn how to model your code into a flow chart, right? Because usually you should learn how to write good documentation for your code. This will allow you also to easily test it, to check it against some specs, right? Which is writing more like professional industrial code rather than just go ahead, you have a problem, start coding, or write all kind of lines of code without thinking of the actual logic of it, right? Good. So an example here, it's a very simple one. We have a 10 iteration for loop that prints the counter itself, right? We have wrote more complex expressions than this. Looking into the flow chart of this, I equals 0 is your initializer expression. And then you go ahead, is I less than 10? So that's your condition. Yes, that's true. Then I do my statement, which is I'm printing the value of I, and then I increment, right? That's the third. So this is the third one here. And this is your initializer, and this is your checking condition, right? Good. Why do I have these comments? Is like from last year. So I just delete all of this and then delete that as well. Interesting. I recall deleting all of this a week ago. You shouldn't have these comments on the slides you have on Avenue. Do you have them? I don't think you have them in the PDF on Avenue. But let me know, right? If it doesn't look good, Let me know I can upload them. Yes means you have them or you don't have them. We do. Okay. Okay. So I should update the slides then. Thank you. Okay. So let's say I want to print 20 stars. And by the way, I have also uploaded an example that takes this simple example like a little bit further, right? So maybe after the lecture as a supplement, you can look into the video that brings those examples. And this example was really from the final last year as well, right? So look into it. Just to let you know, like the example I also solved it with the students in the tutorial last year, and then it came into the final, and not all of the students were able to get it. So make sure you pay attention to the examples and the things we do in the lecture, as well as the tutorial and the videos, etc. Right? Okay, so we want to print 20 stars. So one way to do it is to say, well, I have a counter that goes 20 elements, and then I just print a star. Another way of doing it is to say, well, instead of starting from 0 and stopping at 19, so that's 0 to 19, which is 20 iterations, I can start from 1 and stop at 20, right? That's exactly the same thing, correct? Or, well, it will do exactly the same thing if you start from 20 and then keep decrementing. So here that's an example of a decrement of your progress expression in the for, going from, now you go from 20 to 1, right? We have seen also the decrement as our expression in the for loop in the example where we needed to read 20 elements from the user, put them in an array, and then print them in a reverse order, if you recall that, right? So that's also one example of the decrement. So something that this example shows is your expression doesn't always have to be an increment, a simple increment by 1 or a decrement by 1. The good thing is you can add whatever complex expression you wish to do, right? So you can add 2, you can add 5, it's up to you. So your step for the increment or decrement can really be anything, right? You can really multiply. So that's a general expression, a general valid expression in C code, which can be a multiplication, a division, or anything, right? If I do this, can you imagine how many stars we might print? So I'm starting from 0, checking I is less than 10. That means I have a total of 10 iterations, but then each time I'm incrementing by 2. So it will be 0, 2, 5, Abdul Nasser, thank you, then 4, 6, 8. And then, well, once you increment to 10, it's not less than 10, so you will not go ahead with this iteration. So you have a total of 5 iterations, right? Good. And that's simply, well, it's exactly the same flowchart as before, except that your progress condition or like step condition is incrementing by 2 instead of 1. Good. Then for while, one way to understand the difference between while and for is to look into their flowchart. We said before that for and while are completely equivalent in terms of functionality. They don't add anything. Anything you can do in while, you can do in for, and the other way around, right? But it might be more logical for some use cases to use for, which is when you know the exact number of iterations you want to go through, right? But if you have a complex condition, while might be like easily readable. It might make more sense, right? So here, for while I have a condition, you don't really in while need to add initialization or counter or anything, because this is not necessarily an increment step. So you have a condition. If your condition is true, you would remain in the loop. Otherwise, you exit. Smith, I see your hand up. If you have a question, please go ahead.
No, sorry, that was just a mistake.
Okay, thank you. So there is a question in Ahmed. Please, Ahmed, when you ask questions in the chat, make sure you put a question there. Yep, exactly like this. So here, the question is, does it increment first and then print, or do the other way around? For can seem a very special case from the pre-increment and post-increment, because pre-increment and post-increment applies to the expression that they are used in, which is this expression. If you see this expression, it's placed in the for block. It always comes after the print statement, right? So it doesn't really matter whether you do a pre-increment or post-increment in this example. Why? Because always this expression evaluates after you do your statements of the for loop. So it will always print first and then do the increment condition. Good. Does this answer your question? Ghayat, another question. If it's increment, then Brents wouldn't skip the 0 star. Yes, this is exactly the answer. Is you don't. If you look into this flute chart, this is why flute chart is very important to understand. Is you always have your step condition after the execution of the statements. Okay, not before. Okay, so here, assume we have this for example. If I want to write the equivalent one, while loop, what do I do? First of all, you have three things in your for that you have to pay attention to. You have an initialization, which you have to put before your while loop, right? So you have to initialize I to 1 before you enter your while loop. And then you have your condition, which is basically you have to put inside your while condition. And then inside the while block itself, you have the increment condition, which you have to put at the end, right? So these three things, the first one, second one, the third one, simply what transforms a while loop to a for loop. Good. I would assume that this is more like a revision. In fact, you should have went through all of this in Python, but just to make sure you have all the rules, okay? So the general, well, this was an example. The general thing is, well, if I have an expression 1 condition, expression 2, and while my expression 1 will become before the loop, condition will be my condition for the while, and expression 2 becomes the last line in your while loop. Good. This is how you can transform any for loop to a while loop or the other way around. And this relates really to, I guess, question 1 in the lab, if I remember. Question 1 was asking you to write things in for and while and check how they work, correct? Yeah, so the other thing is, well, if I want to transform a while to a for, what do I do? If you don't have any initializations or increment condition inside your while, then you only have the condition, right? One trick we mentioned before in C for the for is you really can have those as an empty thing. You don't really have to have an expression here, right? So if you just write for like this, it will be the completely, first of all, it's completely valid, but then the second thing, it's completely equivalent to your while loop. You don't need an initialization expression or a step condition like a progression expression. Good. Okay, so do while. Well, we still have these here. Okay. So for the do while, the difference between and do while is one thing we really didn't see in any of the examples we have written before. But simply the main difference between while and do while, because you always check your condition after the statement execution, not before, right? So if you look into, let's start from the while flowchart, because this will help us understand. In the while flowchart, we had some previous logic, and then we had a condition. And then if the condition is true, I do execute the statements. If it's false, I just exit. And then here I return, correct? This is what we had before in the previous slides. That's the while. Compare this with the do while we have blue. So your starting point is exactly the same starting point here. But instead of directly checking the condition, you do first at least one statement execution, right? And that's the main difference between do while and while, is you execute your iterations at least once before checking the condition. Good. So here, one example of how to show that, like while versus do while. Assume that I and n are integers and are allowing the pieces of code equivalent. Let's see if they are equivalent or not. Do they have the same effect all the time? Let's check that. So here I'm initializing I to 1. I check if I less than or equal to n. If that's the case, I print I and then increment I. If I do while, I do exactly the same thing. Initialize I to 1. do the same statements, and then check the like check the condition for whether I equal to n or less than or equal to n. So let's take the questions one by one. Are these pieces of code equivalent? What do you think? They are not equivalent. Why? Yes, they are equivalent. If n is the same as I, it won't run. So Ahmed like kind of put it down to the corner case. Right? So general case. Let's say well, here I is initially 1. So let's say n is 10. Okay. And let's try to trace. That's really what you should do for your exam, for your way of thinking in approaching problems in programming. So I is less than 10 in both cases. So if this is the while and this is the do, I would print I first, right? Because I is 1. And then I increment I, so I print 2, then 3, and then 4, and then 5, and then 6, and then 7, and then 10, and then yes, it's less than or equal. But if I go to 11, it will not be print. So I'm printing this in the while case, correct? If I go to the do while, well, I execute it, so it's 1, and then 2, and then 3, and then 4, and then 5, and then 6, and then 7, and then 8, and then 10, and then I increment 10, I go there, I print it, and then I increment to 11, correct? So in this case, in this corner case, 10 less than or equal to 10. So the condition is true. So I go back to my do while, and then I print, so I printed it already, and then I increment to 11. But then in the 11 case, is 11 no? So that's so what's you guys see you freezing? I guess I'm lagging behind. Is that correct?
You were a moment ago, but you're good now.
Okay, I'm back. Okay, you don't imagine how many hotspots I have, but yeah, sometimes they are the problem because I keep switching network, I believe. So I need to see what is happening. Good. So let's go back to what I was saying. Assume n is 0. So for a while case, I is equal 1. Is 1 less than or equal to 0? That's wrong. Then you will never execute anything. I don't print anything. So the while case, in this case, well, nothing gets out of the screen. What about the do? I equal 1. I go to the do, print I, no matter what is that. There is no condition that I even checked in my path, right? So I will print 0, and then increment is 1 less than or equal to 0. No, so I just stop. So in this case, do will give you a single iteration execution, but while will not execute anything, right? And that's really the corner case difference between do and while, right? In do, you always execute at least once, even if your condition is false. In your while, you don't have that, right? Good. Okay, good. So we still have few minutes. Let me see how far we can go with this theoretical information. So with regard to data types, I guess yesterday I mentioned we have we will go through characters and integers, and especially characters because they are a special case. So we said before that a character is really a single byte, so it's an 8-bit, and it allows you to represent like a single character, a single keystroke in your keyboard, right? Integers are either 16 or 32 based on your machine. And I said yesterday that mostly in most of our machines right now, they are 32. And we went through all of this. Am I repeating what we had yesterday? Oh, no, here we have the valid values, but these notes are from before. Okay, good. So yesterday I briefly went through this, but let's again have the general rules. Just deleting all the notes. That's the ASCII characters. Okay, so most probably we're not going to finish all of this as I intended, but at least we'll go through some of them. So let's see. So here it gives you the valid values. If you apply the rule we had yesterday, you are really able to get all these numbers we discussed before. Because simply yesterday we said if you have a short end that's 16-bit, 16-bit because it's signed, then you can have plus or minus 2 to the power. Well, 8 minus short end 16, is that correct? The power 8 is not that. Well, that's to me something that might not be completely correct. In fact, I need to double check this, because if you have it assigned, then you need, oh yeah, that's 15. Okay, correct. So you have plus or minus to the power 15 minus 1. If you look into to the power 15 minus 1, you will get this number. Okay, and then for the end, again, that's 32-bit. So you have plus or minus to the power 31 minus 1, because you take 1 bit for the sign. And that means this is the maximum number you can have for something as an int. Later on, I will show you a simple code to how to check this number. Like there is a way in C to print this number, in fact, for all the types, to print the limits of your every type. And then long int is 32 bits, which is the same thing. And then if it's unsigned, then you can see that this number is double this number. And the reason we mentioned yesterday is because right now we don't need a bit for the sign. Then you can really have the full 2 to the power 16 bits minus 1, correct? And then the same thing applies afterwards. There is, well, you don't need to know or memorize all of this. Just have a sense of what it means. And there are ways in C to really print all these numbers, right? For floating point really have an IEEE standard that dictates how many bits and what is the representation. Hopefully in a digital design course, you should also deal with floating point numbers, like how to represent a number in what we usually call in digital design mantissa and exponent. I don't know if you cover this in digital design with Dr. Bowman or not yet, but simply there is a way to represent floating point numbers in zeros and ones, right? That's really the challenge there. And then if it's a float, then it's only 32-bit, so it's a single precision. We call in the standard single precision floating point. If it's double, then it's 64 bit, and it's called double precision. And then if I want to see what are my maximum numbers, you would need to include a header file called limits.h, right? For example, if I want to print the maximum value of an integer, that's really a define in this file called int_max, right? This will give you, if you print int_max, it gives you the maximum integer possible value. And then this will give you the minimum value of a short, which should be a negative value. It gives you the maximum value of an unsigned long. So there are in this limits.h, it gives you all the possible values that we had in the table before, okay? And then if you want to do the same thing for the float, then you would use float.h, and it also gives you all the limits. For example, double_max gives you the maximum value that is represented by a double. By the way, this is something that can be used for error checking or handling from a user. Some of you asked me a very good question for lab 1, which is, do I need to check against whether the number that the user inputs is something really within the range or not, right? If you want to do this as like a guard against any misuser behavior, then simply take the input, compare it with your max. Assume, for example, you are expecting an int, but the user inputs something that is very big. You can write an if condition, whether this input is really less than or equal to the int max or not. If not, then you print something to the user saying, well, please input a valid number, right? Similar to the messages you get when you enter a wrong password or something that is not adhering to the rules of your input in the text file. Good. Here, well, it's a screenshot of how to really use short max, for example, or any of the limits here. So the maximum value of a short is this. Usually these things are int because, well, they are from the short type, which is an int. This is why we have the specifier %d. Okay, and this gives you the max number here. Okay. Integer numbers written in decimal. Well, that's the constant, so we know this. Yeah, so if you want to represent, that's something that maybe you wouldn't encounter in any of the lab questions. I would stop in a minute, but I will just have to go through this thing to complete the topic. So simply, this is something I don't think you will see in any of the labs, but usually it exists in some of the professional coding, which is I want to define a number. It's a constant value, but I want it to be represented in a certain way. If you just write the number without any suffix, it's just a normal int, for example, or a normal double, or based on the type. If you want to be represented as a short or a long or signed or unsigned, you can really use some suffix for this. For example, if I write the same thing exactly like 3988 and then add the suffix L, this is telling the variable that you're going to store this in is I want this to be represented as a long int, not a normal int, right? So you have a way to determine your constant representation in that case. Okay. If you want it to be unsigned, it will be like that. And then if you want it to be unlong signed, you can really kind of concatenate multiple of these specifiers or suffixes. Okay. And then you have the same thing. Well, for the floating point, let me see if I should stop here. Yeah, well, okay, so let's stop here and then maybe we can continue on Monday then, because that's too much. Again, I would say if like maybe you should today, if you're working on lab 1, check the videos that I'm going to put on Avenue. Like I put the links for these videos that walks you through some of the lab 1 questions, gives some examples. I guess also the TA did a good job in the last tutorial going through the lab questions. And again, make sure you utilize the office hours and lab sessions to ask questions. Hopefully, after lab 0, you feel now that your effort in the environment setup pays off. You should be doing exactly the same thing in creating a project, in cloning the repository, in pushing the updates. So you shouldn't be suffering with any of that. Okay, is there no way to do something like this? That's definitely possible, but Hauman, and by the way, just before answering questions, I'm done with the technical content. So if you have another lecture, if you want to leave, please feel free to do so. I will stay for a couple of minutes to take questions. Okay. So Hauman, for your question, that's definitely possible, but not all the time you want to directly assign a constant or an immediate value to a variable. Sometimes you use your immediate values in an expression, right? And then, well, it might make a difference if you would like your immediate value to be dealt as a long, right? But what you write here is completely valid. If the use case, like kind of you assign the immediate value to a variable directly. Thanks, Abdul Nasser. I'm happy to hear that Lab 0 really helped in getting the environment going through. And I do understand you might have suffered a little bit, some of you, for the environment setup. But again, hopefully this pays off until the end of the semester. And beyond this, when you go to industry, I would believe you appreciate learning about GitHub at least, and unit testing, and those kind of non-related programming experiences that are important for a professional computer engineer. Questions. Ahmed, sorry, could you repeat why it executes at least once in do? This is how it works, Ahmed, because if you look into the do structure, you don't. Let me quickly go back to the flow chart here. So here, if you start from this point, you execute the statement before checking the condition, right? So we said before that the way the compiler executes in C, it's sequential, correct? So it goes line by line. So here, if I go from up down, I'm going to encounter the statement before encountering the condition. This is why it will execute at least once. Questions lagging. Okay. Oh, thanks, Aiden, also to hear this. I'm happy to hear. Okay, hopefully you don't see it overwhelming. Okay, so it seems that there is no further questions. So thanks everyone, and I will see you next week then. And good luck with lab 1.